Whenever you flip a light switch or plug in your phone, there's an entire invisible world of rules working to keep you safe. It's not by accident that things just work. It's all governed by a standard called AS/NZS 3000, better known as the wiring rules. Today, we're going to pull back the curtain and take a look at this incredible framework.
All right, here's what we're going to cover. We'll start with the why, the real purpose behind these rules. Then we'll get into the most important bit, the difference between Part 1 and Part 2. After that, we'll do a quick tour of the whole standard, look at a real-world case study with RCDs, and wrap it all up by looking at why the whole framework just works so well.
So what's this standard really all about? Well, when you boil it all down, it's a safety document. Its number one job, its whole reason for being, is to protect people, livestock, and property from all the dangers that come with electricity.
And hey, don't just take my word for it. The standard says it right there, right in the very first clause. This isn't just some dry technical manual for electricians. Nope. It's the foundational safety Bible for both Australia and New Zealand. It's about preventing shocks, stopping fires, and making sure nobody gets hurt.
Now, to do all that, the standard is built on a really clever two-part structure. And honestly, understanding the difference between Part 1 and Part 2 is the absolute key to understanding how this whole system works.
Let's start with Part 1. The best way to think about this part is as the Constitution for electrical safety. It sets out the big, fundamental, non-negotiable principles.
You see, Part 1 is all about the why. It defines the safety goals, the outcomes you must achieve. It'll say something like, your installation has to be protected from overcurrent. But notice, it doesn't tell you how. It doesn't name the specific circuit breaker. It just sets the destination.
So, if Part 1 is the Constitution, what's Part 2? Well, that's the detailed book of laws. This is where all the practical, hands-on rules live.
Part 2 gives you the how. It's packed with all the specific, prescriptive rules, the nitty-gritty that electricians and designers use every single day to meet those big-picture safety goals from Part 1. It gives you the turn-by-turn directions to reach the destination safely.
And this slide just shows that relationship perfectly. Part 1 sets the high-level goal and points directly to Part 2, and Part 2 provides the detailed roadmap to meet that goal. They're two sides of the same coin working in perfect harmony.
And this leads us to this really important concept called deemed to comply. It sounds a bit technical, but the idea is simple. It's the bridge that connects the two parts. It just means that if you follow all the specific rules in Part 2, then your installation is automatically considered, or deemed, to meet the fundamental safety principles of Part 1. It's the standard path to getting it right.
So what does this whole rulebook actually cover? Well, this scope is huge. I mean, it covers everything from the main switchboard in your house to the outlet you use to charge your car. Let's do a quick tour through the 8 sections of Part 2 just to give you a feel for it.
Sections 1 and 2, they lay down the groundwork. This is where you find all the core principles of protection, the rules for your switchboard, which is kind of the heart of the whole system, and the requirements for those life-saving devices we call RCDs.
Then, in sections 3 and 4, we get into the actual physical stuff. This covers how cables are run safely through your walls, making sure the wires are all the right colors, and the specific rules for all sorts of equipment, including, and this is a big one now, dedicated chargers for electric vehicles.
Next up, sections 5 and 6 deal with some really critical safety areas. Section 5 is all about earthing, that essential connection to the ground. And then, Section 6 tackles the high-risk challenge of putting electricity in wet areas, like bathrooms and pools, where you need to be extra careful.
And finally, Sections 7 and 8 handle all the special cases and the final sign-off. Section 7 has rules for things like emergency lifts and even home solar power systems. And Section 8 brings it all together, laying out the mandatory inspections and tests you have to do to prove an installation is safe.
Okay, I know that was a bit of a whirlwind, but how does this all actually work in practice? Let's take one really common component, the RCD, and trace it all the way from a Part 1 principle to a Part 2 practice.
So, Part 1 sets the fundamental principle. It says that in high-risk areas, additional protection shall be provided. This protection has to be able to automatically shut off the power the instant it detects a dangerous leakage of current to Earth. That's the why.
And this brings us to a really critical number. An RCD has to be sensitive enough to trip at 30 milliamps or less. Now, that specific number is absolutely crucial. It's the threshold for cutting the power before an electric shock can become fatal. This number, right here, literally saves lives. Now we go to part 2 for the how. And you see, it gets very specific because it knows that not all electrical currents are the same anymore. It breaks down the different types of RCDs, type AC for basic circuits, but also more advanced types like A, F, and B that are needed for modern electronics. This way, the installer knows exactly which device to use for that specific job.
And there you have it, a clear, direct line from the mandatory safety goal in Part 1, provide additional protection, straight to the detailed, practical tools and instructions in Part 2. It's just a perfect example of this whole system in action. So let's just pull back for a moment and look at the complete framework. Because this two-part structure isn't just a random choice, it's what makes the standard so incredibly robust and effective. The beauty of this structure really comes down to 3 things. First, you set those mandatory, unbreakable safety principles in Part 1. Second, you provide a clear deemed-to-comply path in Part 2, so everyone knows how to build safely. And third, and this is the really clever bit, it allows for innovation. Because Part 1 is focused on the safety outcome, new technologies are welcome, as long as they can prove they meet that same fundamental principle.
And that right there is the ultimate takeaway. The AS/NZS 3000 standard gives us the best of both worlds. Rock-solid, mandatory safety goals combined with a clear, practical, and adaptable rulebook for getting there. Which brings me to a final thought. This standard is a living document. It's constantly being updated. So as technologies like electric vehicles and home battery storage go from being niche to being in every home, you've got to ask, how will these essential rules have to evolve to make sure our electrical future is every bit as safe as our present?